The oceans make up a huge part of our world, covering over 70% of the Earth's surface. They're home to millions of species and contain a vast range of habitats, many of which are barely explored. We know more about the surface of Mars than the deep ocean. This is why the 14th goal on the UN's Charter is dedicated to protecting life underwater by trying to find ways to defend it from pollution and overfishing, and aiming to conserve and sustainably use the oceans. Although there are many problems facing our seas, we have decided to focus on how to deal with the growing issue of plastic pollution. Currently, we produce roughly 400 million tonnes of new plastic each year, and of this, about 14 million tonnes end up in the ocean. Plastic pollution is an issue on land, but it is particularly problematic in the sea. Large plastic items can choke and kill sea creatures, and as common plastics take so long to biodegrade, they break up and end up as microplastics. These microplastics can be eaten by marine life and pollute entire food chains, even sometimes ending up in human food. It's predicted that by 2050, there will be more plastic in the ocean than fish. A way to tackle the issue of plastic in the sea is to find a method of biodegrading the plastic, and that's what our idea is all about. Polyethylene terephthalate, PET, is a plastic which is commonly used in disposable food and drink packaging, such as plastic bottles. It's possible to recycle it, but that uses up extra energy, most often obtained by fossil fuels, although less than the energy cost of making new plastic. And so, we tried to find an alternative that doesn't require fossil fuels at all.
Discovered in a compost pile and genetically enhanced by biologists, leaf branch compost cutaneases, LCC, is a type of enzyme that is capable of breaking down PET plastic. The LCC enzymes function optimally at temperatures of around 70 degrees Celsius, and so our proposal is to install PET biodegrading enzyme boxes into binary cycle geothermal power plants. In simpler terms, we want to harness geothermal energy to heat the enzymes to a temperature where they can break down PET plastic best. Binary cycle power plants work by passing the geothermal fluids heated deep underground through a heat exchanger, where they come into contact with a second fluid with a lower boiling point, which then boils, creating the steam needed to power the turbine and generate electricity. The great thing about binary cycle geothermal power stations is that they can utilize geothermal heat sources with temperatures as low as 85 degrees Celsius, meaning that containers full of PET and LCC enzymes, with foam insulation to prevent overheating, can be heated by the same geothermal heat source as the main geothermal plant, and the LCC enzymes will not denature, and nor will the PET be at a temperature too low to be broken down. Our idea is to siphon off some of the geothermal fluid so that instead of going to the main power plant, it can heat the PET and enzymes, which are encased in a separate insulated box in a dilute soap solution with a pH of 7.5. LCC is optimum pH. The pipes can then rejoin the main pipe and the geothermal fluid will be reheated in the ground. At the moment, there are few binary cycle geothermal power stations in the world, but we hope that with our innovation, they can become more commonplace. We feel that our idea can help protect the oceans in two ways. The first is simple. By biodegrading PET, a plastic commonly discarded due to its widespread use in food and drink packaging, less of it will end up in the seas, and that stops it from turning into a harmful microplastic or injuring sea creatures. The second way this will help conserve our oceans is it encourages binary cycle geothermal power plant use, which is a renewable energy source. If they were to have a dual purpose of also biodegrading plastic as well as producing electricity, more companies and governments would be willing to invest in them, as the relatively low temperature required of the geothermal source means they can be installed in a variety of locations. With more of these geothermal plants, we would reduce the reliance on fossil fuels, which release greenhouse gases into the atmosphere and heat the planet. This increase in the temperature of our world destroys the oceans as it bleaches coral reefs, which contain an estimated 25% of all marine life. By lessening the contribution to global warming, this fragile yet essential ecosystem in our world's oceans can be conserved.
Protecting the oceans is incredibly important. They contain such a wealth of species and provide livelihoods for so many that humanity would be lost without them. Although our innovation has its limits, as it can only break down PET plastic at present, it can still contribute to protecting life underwater. Currently, plastic-eating bacteria are rare and expensive, but our innovation may inspire others to research into cheaper enzymes or ones which can break down other forms of plastic, and these can be used in sustainable heat transfer systems. In this way, we can help reduce the presence of PET in our seas.
Thanks for watching!